Hello, my name is Xander. Welcome to the JavaScript for Beginners course. In this tutorial, we're going to focus on numbers in JavaScript. If you are new to this course, you may want to start from the very beginning, in which case head over to the channel, look for a playlist called JavaScript Course for Beginners, and then start from the very beginning. In the previous tutorial, we spoke about variables, the idea of storing values in RAM or memory in our computer so that we can then retrieve them and utilize them within our application. Something I didn't mention within the previous tutorial was this idea of, or the terminology literal. So literal is data values, or we could say literals in JavaScript provides a means of representing a particular or some specific value. So a value could be, for example, a string like this, hello world, or it could be a number, it could be true or false, it could be null. So in terms of values that appear directly within our program, like we see here, we could describe these as literals. Looking at these values here, I could take it that one step further and say, well, this is some sort of textual data, a string, I called it. These look like numbers, so that's how this is different from this textual data. This is a null, and this here looks like a Boolean value, true and false. So loosely speaking here, I have data types. This is a different type of data to this type of data. This is the number data. So in a programming language, each programming language specifies the types of data or types of values it can work with. So here in JavaScript, we have 8 basic data types. And in this tutorial, we're going to just focus on numbers. Over the next couple of tutorials, we'll take a look at those 8 basic data types in a little bit of detail. Now, some of the data types, they need a little bit more explanation because we'll be utilizing them more often than others. And some of these tutorials would be nice and small so we can breeze through them. Right, so let's go ahead and talk numbers. So the general idea, numbers, I don't think that needs any explanation. I think everyone understands in general terms what a number is, but let's break this down a little bit. Now, the first thing for us to understand, in actual fact, about types, these different 8 types that we're going to try and introduce to you, is that we can categorize them into primitive types and object types. Now, for this beginner's course, we will go through the 7 primitive types, and then that, when I mentioned there are 8 different types, the 8th type being object types. Now, we will spend a little bit of time on object type, but we'll probably do that later on in the tutorial, in this course, because it is a little bit more advanced. So let's just talk about the biggest difference between primitive type and object types. And that is that the primitive type is immutable. Now, this is a word that if you haven't come across it before, is a very popular terminology utilized for something that cannot be changed. So immutable means that we cannot change it, where in comparison, the object type is mutable, which means it can be changed. So let's go through a quick example. Now here what we have is a list or array of fruit. So don't worry about understanding this just yet, because we haven't covered lists or arrays. That's something that we'll cover later on in this course. Now, generally, if we wanted to maybe access something from this array, we would maybe try and do that by saying fruit. Fruit. Let's get our fruit list, and we'll grab the first item in position 0 here. We'll grab the apple, and let's just say, well, let's just print this out actually. So that's console.log, and we're just going to print it out so that we can see that we can access that first item here. So no, if you are new to this tutorial series, you'll need to install Node for this. So Node and then the name, and there we go. So we put output apple, so you can see that we can access different items here in this array by using their position. So what we can do here then potentially is try and grab one of these. So from our fruit list, let's go ahead and just grab the first one. If you remember from the previous tutorial, we were able to change the value of a variable by grabbing the identifier here, and we've identified what we want to change. this position here. So we want to change apple to maybe another fruit. So let's go ahead and try and do that. So here we have a string type. So we're going to need to add double or singles. So I just add the doubles there, and I'm going to add a new value. So let's go for a nice plum. So we try and do that, and let's just run that. Everything looks absolutely fine, but let's just go ahead again, and we're just going to output the fruit list to see if it's changed. And you can see that it has. So it worked. We were able to mutate, or we made a mutation on the existing value. In this case, the existing value was an array list, or more specifically, an array object. So an object, if you remember from the previous slide, if it was that way, from our previous slide, we mentioned that object types are mutable. We can change them. So as I mentioned, primitive values are immutable. So let's just go through a simple example here of creating a primitive value. So let's say let fruit equal, and we're just going to set up. So here we're using a string type, which is a primitive value. So let's just call this apple. So that's what we have here. This type of value we're working with here is going to be a string. And that type of data is, like I said, a primitive value. So let's go ahead and try this again. So we're going to say fruit from fruit. Let's just grab the first item. So let's just console log that. So we output that, and we'll output A. Now notice what we've done here is that we've grabbed the first item from apple. So what we're seeing here is that we have the ability to interact with this string and to extract individual letters. Just run that again. You can see now I have the P. So in position 1 is P. So let's utilize this concept similar to what we did here in position 0 was apple, but this time we're able to grab the individual letters. So let's take the first letter here, which is A, and let's now do something with it. So let's just see if we can change that now. So let's follow the same type of pattern like we've done before. So we're going to say fruit, and then let's just grab the A letter, and we're going to change that into another value. So let's change it into a lowercase a, for example, and let's just console log that to see if we've made any changes. So output fruit, and then we give that a go. And notice that this time no changes were made because, like we said originally, primitive values, in this case we're utilizing a string, a primitive value or primitive values are immutable, so we can't change them. If you've worked with any other programming languages, you probably already know a little bit about data types. And maybe you're already familiar with different data types, including integers, short, long, floating point. Maybe you come from like a database background. Then these type of things make sense. If you are completely new to programming, you will find with different programming languages, there are different types. So it's well worth understanding what they are before you start utilizing the language. So here in JavaScript, the number type is always stored as a double precision 64-bit floating point number. What's really interesting is this format is defined by the IEEE 754 standard. So you can go ahead and go to Wikipedia and have a look at the IEEE 754 standard for floating point arithmetic. And this technical standard is quite interesting. It's one of those things that you would read on the toilet. And this would take you into some different aspects of working with numbers and also introduce you to this idea of single and double precision floating point values. This level of information is not necessarily a level of information that you're going to need to start using number in JavaScript, but as you move deeply or deeper into your project, in some specific projects where potentially precision is very important, then that's where you're going to start really kind of going into that level of information. So let's just say that there is a lot of numbers that we can represent using the number type in JavaScript. And here's just I won't pretend to tell you off the top of my head what type of number this is, but these are the values that we can work with here utilizing the number type. Let's just get back into the practical aspect here. Right, so working with numbers. So here we have the data type, which is number. Now, that doesn't mean that we can't represent different types of numbers. So let's just go through this. So the first one, a familiar type of number, is described as an integer, which is a base 10 number. So base 10, here we're looking at maybe 0, 1, 2, or 1, 10, 100. So these are all base 10 numbers, and these can be described as integer literals. What we're looking at here, I think I introduced in the previous tutorial this idea of using separators in numeric literals. So here we can, for example, utilize the underscore in order to visually separate the numbers, so it makes it easier for us to work with the numbers. So this is all valid syntax here in JavaScript. So let's just go ahead and just see that in action. So let's just set up the variable x, and let's just say that x now equals, let's just go for this number here, and then console.log this. So that should return, that's not going to return, let's run the right file. So that's going to return the number without the underscore. Remember, these underscores are just for us to utilize it as a separator to help us visually see and understand the number. So typically you might start off utilizing this base 10 integer format, but eventually you might want to move into other formats. So of course, JavaScript will accommodate you in that respect. So for example, if you're using base 16 hexadecimal integers, we can utilize that, of course. So if you are new to what a hexadecimal character is, so this values 1, 2, 3, 4, 5, 6, 7, 8, and 9, and then A, B, C, D, E, and F. So we have 16 values here in this base 16 hexadecimal format. So we can work with numbers in this way. So for example, here we might say now x equals, and then in the hex we normally start with say 0x, and then we then specify two values. So let's go ahead and specify, for example, AA. So capitals, not case sensitive here. So A is referring to this character here. So what we got here then is, if we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So A is the 10th value here. So in actual fact, what we're doing here is a calculation. So this calculation is 10 now times 16. Remember, we're using hexadecimal format here. So 10 times 16. So A is 10, the 10th value here, times 16 plus 10. So if we were to go ahead and console log this, we produce 170. So as of ES6, we can now express integers in binary, base 2, and also octal. So we just need to remember the prefixes here for that. So let's go ahead and, for example, binary. So let's say x now equals, so we need 0 and then B for binary, and let's go for 1, 0, 1. Okay, so that's going to be the equivalent to saying, for example, now we need to get the format right here. So we've got three values here. So we're working at 4, 2, and 1. So here we're going to say 1 times 4 plus 0 times 2 plus 1 times 1. So that's the calculation we're doing there in this case. So let's just go ahead and, oh, not console log that. So that gives us 5. 4 plus 1. So obviously 0 times 2 is 0. So 4 plus 1. Okay, so that's binary. And then we can also, like I said, work with base 8. So that's going to be, for example, x equals, and then working with base 8, so we need to use the O octal and then the numbers. So as we get to bigger numbers, precision becomes somewhat of a problem in some cases. So generally with integers, that's, remember, a number without a exponent notation. So for example, a floating point, which we'll discuss in a second. This generally is going to be accurate up to 15 digits. So take this example here, for example. If we were to just print this out, you'd imagine it's going to print out 99999, but in actual fact, we get this rounded number. And that's just to kind of showcase the idea that things get a little bit different as we start to scale up in terms of precision. With the JavaScript number type, we can also work with floating point literals. So a floating point is one that has a decimal point. So for example, 3.14 pi. So we can also represent floating point literals using exponential notation. So here, for example, the notation is going to be something similar like a digit and then dot digit. So, D dot, D dot D. So for digit, so digit and dot digit. And then generally we use the lower or the capital E. And then after that, we then have an optional plus or minus. So to the power 2 plus or minus. And then we have the final digit. So you might see something like DE5. Okay, so if we wanted to express, say, 1.1 times 10 to the power of 10, we could say that x equals 1.1 E10. So that's 1.1 times 10 to the power of 10, for example. So, or else we might want to use the minus. So 1.23 E minus 5. So there we have 1.23 times 10 to the power of minus 5. This can give us a way of expressing larger numbers or performing additional calculations. So although we're not going to explore this in much detail here, it's worth pointing out also that floating point arithmetic is also not always 100% accurate, although there are ways of working around this. But like I said, we're not going to go into that much depth at this point, but let's just go for a simple example here. So let's say we had 0.2 plus 0.1. So you would imagine what's going to be printed here is going to be 0.3, right? So console.log, let's have a look to see what we return. And you see what we returned here is 0.3000004, so not quite 0.3. So depending on how accurate you want your calculations to be, of course, you just need to be careful of these accuracy issues. So as we expressed earlier, integers, or the number type, can support or is accurate up to 15 digits. But of course, data is getting much larger nowadays, and we need to be able to work with much larger numbers. So there is another data type where we can work with much larger numbers, and that's the BigInt type. So let's just take a quick look at this. So this is the BigInt. So very simply, to work with this, let's go ahead and set up a value, a large value. And then to utilize a BigInt, then basically we just define the n on the end here. So something I didn't mention, which I was going to, which I've forgotten, which I do apologize. I was going to introduce the type of. So let's use console.log here. And what we're going to do now is use type of. So this is going to then tell us what type of data we're working with. So let's go ahead and just run this. And you can see here at the bottom, it says BigInt to indicate that we're using or working with a BigInt. So if I remove the end, or you can see we're now working with the data type number. And then if I were then to put this into a double or single quote, I'm then told that I'm using the string data type, or else I might use, for example, true or false, and then that becomes a Boolean. So I do apologize, I was meant to mention this earlier, but data type of provides a way of identifying what type of data that we're working with. So clearly here, we're now working with this BigInt data type. If you have forgotten what is the largest number you can safely work with without compromising, that's the one, reliability and security, you can utilize number.maxSafeInteger and it will return the number. And you can see this in play, because if I were to go ahead and just let's do a simple test here. Let's x equals, let's just check, see if that is equal to, for example, yeah, so this is the largest safe number. So let's go for one more. And let's just see if this number here too represents 3. And you'll see that there's a little bit of rounding here. So let's go ahead and just print x. And you can see that we return true. So this value apparently is equal to this value here, which if you look at it, it's not, of course. But because of precision and the rounding, it rounds up to 3. So we can go the other way, of course. So we have the number.minSafeInteger as well, if you wanted to have a look at that. So that gives us a brief introduction there to numbers, the different type of numbers that we can generate, including BigInt. When it comes to calculations, there are some rules here, and we're going to focus on a separate tutorial where we discuss arithmetic operators and simple maths with numbers. So we'll focus and we'll look at that as and when we come across that tutorial. So like I said, hopefully that gives you a nice introduction into the number type and utilizing different number formats, and giving you some basic parameters and underlining principles to help you move forward and your understanding of JavaScript. Thank you very much if you have got right to the end. This tutorial isn't going to be for everyone for sure. Hopefully I've given you some additional information that you haven't seen or read in other books or tutorials. That's the general idea. If you have any suggestions on how to improve these, always like to hear that, or if there's something specific that you like to see, then by all means just drop a comment in the video and I'll try and accommodate you as best as I can. Thank you very much for listening, and I hope to see you in the next tutorial.